The James Webb Space Telescope has transformed the way we see individual galaxies, stars, and distant cosmic objects. But another space observatory is now changing our understanding on an even larger scale. The European Space Agency's Euclid Space Telescope isn't searching for spectacular close-up images. Instead, it's creating one of the largest and most detailed maps of the universe ever attempted. Launched to answer some of cosmology's biggest questions, Euclid is positioned near the Sun-Earth L2 Lagrange point, nearly 1.5 million kilometers from Earth. From this stable location, it can observe enormous regions of the sky without interference from our planet. Unlike telescopes that focus on individual objects, Euclid surveys millions of galaxies at once. Its mission is simple in concept but extraordinary in scale. To understand how the universe has evolved over billions of years, and to uncover the invisible forces shaping everything we see. One of Euclid's most important goals is studying dark matter. Dark matter cannot be seen directly because it neither emits nor reflects light. Yet scientists estimate it makes up most of the universe's matter. How can something invisible be mapped? The answer lies in gravity. According to Einstein's theory of general relativity, massive objects bend the path of light traveling through space. This effect is known as gravitational lensing. By measuring tiny distortions in the shapes of millions of distant galaxies, Euclid can estimate where invisible matter must exist. Instead of photographing dark matter itself, the telescope reveals its presence through the way gravity bends light. The result is something remarkable. Scientists can build enormous maps showing where hidden matter is concentrated throughout the universe. When Euclid released its first observations, astronomers were amazed by both the clarity and the sheer number of galaxies visible in a single image. Areas of the sky that once appeared almost empty suddenly revealed countless distant galaxies stretching across billions of light years. Many of these galaxies had never been catalogued before. Among the discoveries were hundreds of faint dwarf galaxies that had escaped previous surveys. Although much smaller than galaxies like our Milky Way, dwarf galaxies play an important role in understanding cosmic evolution. Their locations help researchers trace the distribution of dark matter throughout galaxy clusters. As scientists examined the new data, an extraordinary pattern became increasingly clear. Galaxies are not scattered randomly across space. Instead, they form an immense interconnected network known as the cosmic web. Gigantic filaments of galaxies stretch across hundreds of millions of light years. These filaments intersect at dense clusters while enormous regions between them contain relatively few galaxies. For decades, computer simulations predicted this structure. Now Euclid is observing it with unprecedented detail. The visible galaxies appear to trace an invisible framework built largely by dark matter, rather than galaxies creating the large-scale structure. It may be the hidden structure that guided where galaxies formed in the first place. That realization changes the way we think about the universe itself. Instead of being a collection of isolated galaxies, the cosmos appears to behave like a vast interconnected network shaped by gravity over billions of years. And Euclid has only just begun exploring it. While Euclid's first images are already impressive, they represent only the beginning of an ambitious 6-year mission. The telescope is expected to observe billions of galaxies across more than 1/3 of the sky, creating the largest 3-dimensional map of the universe ever assembled. Every observation allows scientists to look farther back in time. Because light travels at a finite speed, observing distant galaxies is like looking into the universe's past. Some of the galaxies Euclid detects emitted their light more than 10 billion years ago, when the cosmos was only a fraction of its current age. This allows astronomers to compare galaxies from different eras and watch how the universe has evolved over billions of years. Early analysis has already produced intriguing results. Some regions appear to contain large-scale structures that may have formed earlier than certain theoretical models predicted. If future observations confirm these patterns, scientists may need to refine existing ideas about how galaxies and galaxy clusters evolved after the Big Bang. That possibility makes every new observation valuable. Euclid is also transforming astronomy through the enormous amount of information it collects. Each survey contains millions of galaxies, far too many for researchers to examine one by one. Instead, astronomers increasingly rely on artificial intelligence and machine learning systems to identify patterns, classify galaxies, and detect subtle gravitational effects hidden within the data. Rather than replacing scientists, these advanced tools help uncover relationships that would otherwise remain invisible. Perhaps the most remarkable lesson from Euclid is not simply the number of galaxies it observes. It is the realization that most of the universe remains invisible. Ordinary matter, the stars, planets, gas, and dust that make up everything we can directly observe, accounts for only a small fraction of the universe's total content. The rest appears to consist primarily of dark matter and dark energy, mysterious components that continue to challenge modern physics. Dark matter provides the gravitational framework that helps galaxies form. Dark energy appears to drive the accelerating expansion of the universe. Although neither can be observed directly, their effects shape the evolution of the cosmos on the largest scales. Euclid was specifically designed to study these hidden influences with unprecedented precision. As its survey continues, scientists hope to answer questions that have remained unsolved for decades. What exactly is dark matter? Why is the universe expanding faster over time? How did the first cosmic structures emerge? These are among the greatest mysteries in astronomy today. Yet perhaps the most inspiring aspect of the mission is how much remains unexplored. The images released so far represent only a small percentage of Euclid's planned observations. The overwhelming majority of its survey still lies ahead. That means countless galaxies have yet to be analyzed. New galaxy clusters remain undiscovered. Previously unknown gravitational lenses may still be hidden within the data. And entirely unexpected phenomena could emerge as researchers continue studying the universe on its largest scales. Euclid reminds us that the universe is not simply larger than we imagined. It is more connected, more structured, and more complex than earlier generations could have envisioned. Every new observation strengthens the idea that galaxies are woven together by an immense cosmic network stretching across billions of light years. Piece by piece, Euclid is helping humanity build the most detailed portrait of the universe ever created. Not by focusing on a single galaxy, but by revealing the invisible architecture that links them all together. And as this extraordinary mission continues, one thing becomes increasingly clear: the greatest discoveries may not come from finding something entirely unexpected. They may come from finally seeing the hidden universe that has been surrounding us all along.